12-5 Scatter plots. Okay, our objective today is to plot data points in the coordinate plane and interpret the scatter plots. So by the end of this, you should be able to kind of analyze a graph with scatter plots and decide if there's correlations or non-correlations. So here's some information from some type of source, and it's giving us the years that SUVs were sold and how many were sold each year. So to the right we have a graph, and we're going to plot those points. So at the bottom we're going to put the years, and on the vertical axis, the up and down axis, we're going to put the number of vehicles sold, and at the bottom axis that's going to be that's also known as the horizontal axis, that's the years. So we start plotting our points in 1991. It was 0.9, and then we had 92 is 1.1 million, 1.4 million, 1.6 million, 1.7, 2.1, 2.4, 2.7, 3.2. So what do you notice about this? Well, let's predict the sales in 2000. Do you think the sales are continuing to go up? Do you think they went down? Do you think they stayed the same? Using what we know here, what would you predict? Well, you'd probably predict that they're going to go up. Now, what might cause SUV sales to go down? Can you think of any reasons why sales might not increase or might actually decrease? And there could be reasons. It could be gas prices. They could be not trendy anymore. You know, people don't like SUVs, whatever. They can find out that they're unsafe or whatever reason. So scatter plots can't be perfect, but they can predict trends. So if we look at this scatter plot, there seems to basically, there's a line that's going up from the left to the right. So the trend is increasing. And what increasing means is as the year goes up, the SUV sales go up. This is what's known as a positive correlation. So let's talk about correlations here. Positive correlation, or trend, is when one set of values increases, the other set tends to increase. So the more practice time you have, the better you play. Most people would agree with that. You're not going to get to be a superstar by sitting on the couch watching TV. Now, a negative correlation is as one set of values increase, the other set tends to decrease. And again, kind of going with the sports theme here, the harder you train in running, the faster your time. Then you might have something that has no correlation. That might be the number of students in Mr. Gore's class and how good looking he is. Doesn't really change. The more students doesn't change how good looking I am. So that would be no correlation. So here I want you to look at these, and I want you to decide, do they have a positive correlation, a negative correlation, or no correlation? So let's look at A. Look at those dots. Do they look like they're forming a line? No. So this would be no correlation. Now I want you to look at the graph below that, B. So look at all those points. Do they tend to form some line that you can see? Nope. Another no correlation. So let's look at C, top middle. Look at those dots. What do they seem to be doing? Are they going up, down, or just all over the place? These tend to be going down. So this is going to be a negative correlation. If you look down below that, D, do they seem to form a line? No, they kind of form a circle in a way. So that would be no correlation also. E, do they seem like they're forming a line? I would say yes. This would be a positive correlation. As one goes up, the other goes up. And then our next one, that has a constant correlation. It doesn't really change too much. It's going pretty much just straight across. Alright, so let's look at CD sales in the U.S. Here's our information from 1990 to 1996. These are the number of CDs sold in the millions. So that's 287 million, 333 million. Would you take a moment and graph the number of CDs sold for each year. So pause the video and come back to it when you've plotted your points, and then you can see, did you put them in the same spot I did. So for 1990, I got 287, and then we have 333. Now, because we're skipping, we're going by twos here, 2 million, 200 million, 400 million, so on. So if we plot our points, see where we're at, 1994, 95, 96. So now, oops, I want to go back to that. Sorry. Now, do you, okay, 1, 2, 3, 4. Okay, do you think that CD sales continue to increase? And do you think they're still increasing today? Why or why not? What might affect CD sales? Hopefully you're thinking, hey, people are buying MP3s, people are on iTunes, people are pirating music, all that stuff. That affected CD sales. CD sales are going down now because people don't buy CDs. Ask yourself, when's the last time you bought a CD? Okay. So, here's a little video.
Behold, barbed wire. But where did it come from? Meet Joseph Glidden, born in New York in 1813. Joseph was originally a school teacher in New York, but by the time he was in his late 30s, he'd already moved to Illinois and taken a job as the sheriff of DeKalb County. You may have heard the expression, good fences make good neighbors, before. This was especially true in DeKalb at the time. Cattle ranchers needed reliable ways to control their herds, and farmers needed fences to prevent animals from trespassing into their crops. In 1873, Joseph saw an interesting demonstration. A man named Henry Rose had a new concept for fencing. His design featured a wooden rail with spikes protruding from the sides of the rail. This idea intrigued Joseph, but he was certain it could be improved. He buckled down and went to work. By 1873, he'd patented the stuff of genius that we call barbed wire. Here's how it works. Joseph used a coffee grinder to sharpen wire barbs, which he placed at regular intervals along the smooth wire. He twisted a second wire around the first to hold the barbs steady. Joseph wasn't the first person to invent a form of barbed wire. However, his patent is the basis for the modern barbed wire used in the United States and across the world today. So, how genius is this inventor? On the American dream scale, Joseph gets a 4. He didn't just take a pre-existing idea and improve it, he also won a 3-year legal battle for the rights to his patent. On the benefit to humanity scale, he gets a 3. Barbed wire gave farmers and ranchers an effective way to control their livestock and protect their property. Today it's used by thousands of industries across the world. On the ripple effect scale, he gets a 4. Joseph's barbed wire design is still in use across the modern world.
Let us know what you think. Email genius@howstuffworks.com. Also, be sure to...
All right, that's it. And we'll talk to you later.